Okay, so as I mentioned at the beginning, the hash functions are used everywhere. They use in data integrity, and they all can also provide a measure of authentication. For example, let's say if I gave you a book, and how do you know when I send it to you, this book is not changed? So what I can do, I can provide you, I can run the hash function of this book, and I can also send you the hash value of the book along with the book. So when you receive the book, you can run the same hash function, and then you can compare these two values. If they are same, then you know that the book is not being changed. So this provides a sort of data integrity, means the information of the content is not being changed. They also use heavily in the storing the password. So these days especially, you can, instead of storing the password in a file where they are not secure, anybody can get access to those passwords. So rather what we do, we store them in hash values. So we take the password, we calculate the hash, then we store the hashes of the password, and whenever somebody wants to log in, we take the password, we run the hash again, and we compare the value of the hash with the value of the hash stored in a database. They also been heavily used in digital signature. We'll see more details when we get to the digital signature section. They also used for authentication. They also used for error detection in communication, and the Bitcoin and especially cryptocurrency, they heavily use for the providing a privacy. What that means is, especially in the Bitcoin, there are a lot of application of these hash function. We use them to generate the blockchain addresses, which means instead of having your username or your name on the blockchain, you've been represented by the address, which is pretty big number because the hash value is 64 hexacharacters. We have a different algorithm for generating the addresses. We'll see later on as we go into the blockchain section and the Bitcoin section. But again, instead of having your name and your information exposed to the public, you have a representing blockchain address, which is pretty big, and somehow it will provide us some level of privacy. We'll see it's not fully completely anonymous, is a pseudo-anonymous, but we'll see that later when we get to the blockchain section. Also in the blockchain, hash functions are used to linking the blocks together. They're used to verify the integrity of the block, and this is where we say the blockchain is immutable. And how? Because we calculate the hash of every block, and if anything change, we can discover right away by running the hash value of the previous and the existing block, and we can compare, and we'll see is anything changed, then the hash value will change, which triggers that there is something, the content has changed for the block. Also, they've been used for the proof of work concept, we call in the blockchains. We'll discuss that later, but there's another application of the hash function in the blockchain. And also they've been used for identification of the transactions. So as you can see, the hash function is heavily used everywhere in the digital world, and especially in the blockchain. So let's continue with some of them. There are many hash functions are in use today. Some of them I have listed them here. The top one is MD5, which is Message Authentication Digest, and as you can see, I have written here broken, means there's a collision found for this, so it's provided 128 bits output. The other one is SHA1, Secure Hash Algorithm 1. Collision has already been found for this provides 160 bits output, and it's also broken. So from the practical perspective, these two should not be in use because they are not secure anymore. Currently, these days, the SHA-2 is being used heavily. It provides two options. You can have 256 bits, or you can have the 512 bits, or there's some other variation. The SHA is actually a whole family of the algorithm, so it provides a multiple option for in output. But SHA-256 is it's pretty much being heavily used these days. It's a standard by US, whereas the RIPE MD, which is 160 bit output, is an European standard. And there's another one which is the SHA-3. which is the modified version of the protocol we call the cat check, which is also provide 256-bit output. So pretty much SHA-3 and the cat check are pretty same. A little bit difference in there, but I will say just consider SHA-3 is a cat check. Okay, so these are the few hash function being used today, as I said, and all of them, especially SHA-2 and RIPE-MD and SHA-3, they all been used in a blockchain heavily. Especially Ethereum use the cat check, whereas the Bitcoin use the RIPE-MD and then SHA-2 for the blocks and the other purposes. Okay, so as you can see, the hash functions are very important. They have a lot of usage in modern day cryptography and also in the digital internet world, and also as you see now in the blockchain and the Bitcoin especially. So let's take a look at some of the demo, and you can try by your own calculating the hash of different values. And let's take a look in the next section.